So problems, like physics problems, are good because usually it's a chance for somebody else to solve them. In comes Neil Bohr. Um, so basically, what he comes up with is the Bohr model, which is that electrons have stable orbits at certain fixed points. So at certain radii. So he's the one who comes up with, we've got our charges in the center, and then the first ring can hold 2 electrons. The second ring can hold 8. So 1, 2, 3, 4, 5, 6, 7, 8. And then the third can hold 8, and so on and so forth. So basically, in between, if an electron's in between these orbits, it's going to radiate away energy, which actually explains why different elements emit different frequencies of light, and that's why different things have different colors. And that's why we can tell what atoms exist in the sun without astronauts having to go there and scoop full of the sun up and then checking it out in the lab later. Because every type of atom emits different types of light energy based on the spacing of these radii. Okie dokes? So, now in comes de Broglie. And de Broglie says that electrons aren't particles, they're waves. So basically, what he found was if you pass electrons through, so there's this famous experiment where if you put light through a double slit, you don't get like 2 dots of light, you get basically light everywhere with this weird interference pattern. We'll talk about interference patterns when we talk about waves. But what he found out was if you do the same thing with electrons, you get the same result. You get that electrons aren't like firing, it's not like throwing a baseball through a door. If you, it doesn't have to choose one door. They actually end up making this weird interference pattern, which actually peaks in between the 2 doors, as they're coming through. So that's weird. So electrons aren't particles, they're waves. And then he comes up with his own model, which has the nucleus at the center. And then basically, if you imagine concentric circles around it, so there's a wave that exists around this one, but it's what we call a standing wave. So it meets up with itself. If you have just one standing wave, it's going to look like that. If you have 2, it ends up looking kind of like a peanut. I kind of peanutted it way too much over here. I should peanut more like that. Now, the interesting thing about this is, well, I can fit a peanut on here this way too, and then I can fit another one coming out this way. And this actually explains why the periodic table has this shape that it does, because you can have 2 electrons going around like this. Each one, you can have 2 going around like that, 2 going around like that. So that explains why you get 8 electrons in your second layer, but only 2 in your first one. And then, as you go out into bigger and bigger energy levels, you get more and more waves, and they get weirder shapes than peanuts. But I can't draw a peanut. I'm not going to draw the next harder thing. The last guy is Schrodinger, and Schrodinger uses something called the Heisenberg uncertainty principle. So Heisenberg uncertainty principle is this tenet of quantum mechanics that says you can't know the location and momentum of an object with infinite precision. So basically, you cannot know the exact location and the exact momentum or the exact velocity of an object without there being some amount of uncertainty. So what he has is he has the nucleus at the center, and then the electron cloud is like this. Basically, it's an area of probability. I can't really draw it because, first off, it's existing in 3 dimensions, and, it's more complicated than I can draw. Anyways, there we go. That's atomic history. Other things happened after Schrödinger. We have Chadwick needs to discover the neutron. Before Chadwick discovered the neutron, they thought there were more protons paired with electrons in the center than there actually are. And then Chadwick comes around and he goes, there's neutrons too. And then after that, a whole ton of crazy stuff where it's like protons and neutrons aren't even fundamental particles themselves. But that's for another day.